This video is intended to be supplemental instruction for students who miss any one of lessons 2, 3, and 4 when we're doing the area model factoring in class. It is not going to be as detailed as all of the notes because I'm going to try to fit all 3 lessons into one 30-minute video, which is going to be a little bit tight. So be prepared to pause, be prepared to cross-reference this video with the available notes in order to try to put all the pieces together. I just didn't want to leave students without any kind of instruction on area models and how to factor with them. So to give you the idea of how an area model works, we are looking at a rectangle. And if you recall, the area of a rectangle is equal to the base times the height. And that would give you the amount of space that you have in that rectangle. So for example, if the height of the rectangle was 2 and the length or base of it was 3, we would say that the area was 2 times 3 or 6. And then we would put some kind of like square units on that. And that's because, like, let's say you had inches, okay? So if you have inches on that, what it would be in this step right here is 2 inches times 3 inches. Well, 2 times 3 is 6. And then inches times inches, if you think about, well, what's like 2 times 2, that's 2 squared, or 4 times 4 is 4 squared. Well, inches times inches is inches squared, because, you know, math is consistent like that. So that's the idea between, behind the area. So if you're wondering, like, well, why is she talking about area model? Like, that's kind of weird. So here's the deal. If you go back to what we were talking about in the greatest common factor, what you've got going across the top is one factor, and then you have another factor on the side. And when you have a factor times another factor, you get the product. So to get the idea with this, we want to go in the what we would call the forward direction first. So if you have some rectangle like this and you wanted to find the area, okay, you could find the area, we'll just call them A1, A2, A3, and A4. You could find the area of each individual box and then add them up, and that would give you the area of the whole rectangle. So pause and rewind that if you need to, okay, to get that idea. What we're doing is we're finding the area of each individual box, and then if we add all those areas up, that would give us the area of the whole rectangle. So suppose you have x and then a plus 4, and then you have an x and a minus 3. Okay, and so what this is the problem, x plus 4 times x minus 3. We're factor, base, height. We're going to multiply these together and get the area. So x times x is x squared. X times 4 is 4x. X times negative 3 is negative 3x, and negative 3 times positive 4 is negative 12. And if you want the area of the whole rectangle, you would add all of these up. And you actually can take the little shortcut and combine these two. You can even combine them as you go if you want, and that would just become plus 1x minus 12. So that's how the area model works with multiplication. I'll do one more quick example with that. So suppose we were doing 2x minus 3 times x plus 5. And it doesn't matter where you put the base times the height, like the product would be the same either way. So I'll go ahead and do 2x minus 3 across the top, and then x plus 5 down the side. X times 2x, well, that's 2 times x, or 2x squared. It's only the x that is being squared there, not the 2. The 2 is only in there once. So that's like 2x times x, or 2 times x times x, or 2x squared. Never in a million years would I want you to write that out, okay? Just I do want you to have the opportunity to see it. X times negative 3 is negative 3x. 2x times 5 is 10x. And then positive 5 times negative 3 is negative 15. And then not 100% of the time, but most of the time when you look on those diagonals, those will be your like terms. And so to get the area of the whole box there, we would add the individual areas up. So we would have 2x squared. You can combine these in your head if you want. So 10x minus 3x is 7x. And then we have the minus 15. Okay, and one of the really good things about this is it actually works for all kinds of polynomial multiplication. And I know I just threw a word out there. I threw out the word polynomials. Don't let it freak you out. Math is consistent, okay? So suppose you had x times 3, and then you had 2x squared plus 4x minus 1. Well, you don't have to freak out because math is consistent, and the principles that work for one thing work for the others. It's just going to look a little bit different. So we might have the x minus 3 across the top, and then across the side we would have 2x squared plus 4x minus 1, and then we're going to do the exact same thing. So really the only new thing there is somebody might have to show you how to set it up. Once you know how to set it up, like you should be able to extend that to pretty much anything. So 2x squared times x, that's 2 times x times x times x. So that's 2x to the third. 2x squared times negative 3 is negative 6x squared. I should probably check my phone. 4x times x is 4x squared. 4x times negative 3 is negative 12x. X times negative 1 is negative 1x. And negative 1 times negative 3 is positive 3. And then once again, you'll see that your like terms are on those diagonals. So to get the area of the entire rectangle, we're going to add up the individual areas. So we have 2x to the third. 4x squared minus 6x squared is negative 2x squared. Negative 1x minus 12x is negative 13x. And then we have the positive 3. And so that's how the area model works for multiplication. When we factor, we're actually going to be going in the opposite direction. So here's what we're looking at for factoring. When we're factoring, we're going to start with something that looks like this. Okay, so we're going to start here, and we're going to end with something like this. Okay, so we're going to end here. And we're going to use a rectangle to do this. Now, there's tons and tons of strategies to do this. I've taught it many different ways myself over the years that I've taught this. And this year I am trying something new. I am trying it with the rectangle. And so the first example that I do is going to work you through the process that's laid out in the notes. And hopefully you'll be able to follow along. I'll do what I can to color code some stuff as we go. So this is the example that we have. We have x squared minus 6x plus 8. And I do want to emphasize that a is 1, b is negative 6, and c is 8. Please do not put x's in there. Like a, b, and c are always only ever numbers. They are never, ever attached to an x in any way, shape, or form. So what we're going to do is set up the rectangle. Okay? And we know that it's going to look something like this. And we know from experience, looking over here, we want to look at similar problems, that the x squared is going to end up in the upper left and the constant is in the upper right. The tricky part is coming up with these two. So these two right here, we should be okay. Right here, x squared is in the upper left, constant is in the lower right, and then we're going to have to develop a strategy for coming up with those ones. So we're going to start by placing the x squared and the 8 in their respective boxes. And you can explain that because if you've done enough of the multiplication, you know that that's going to work. Now, here's the key question that you need to ask yourself. Okay, this is like super, super, super key. We want two numbers that multiply to A times C. Now in this case, A is 1, so it's really just C, okay, because 1 times 8 would just be 8. And add up to B, that middle value. So in this problem, we would do 1 times 8, which is just 8, okay? And again, most of the time people won't even say that when you're doing this kind of problem. Yeah, they just won't even say it. So we want them to multiply to 8, and we need them to add up to -6. So we want them to multiply to that and add to this. You just have to know that. You absolutely have to know that. If you do not do enough practice problems, you don't devote any time to memorizing it, it won't be possible for you to do this with any strategy. So this question that we're dealing with there, absolutely have to know it. It's not a negotiable. So two numbers that multiply to A times C and add up to B. So we do A times C and we get 8. And now we need to figure out, well, what numbers multiply to give me 8? Well, obviously 1 times 8, but there's no way I can get a -6 out of this. If I add them, I'll get 9. If I try subtracting them, I'll get a 7, but clearly not a 6. And once you add and subtract them to get your candidate numbers, you can deal with whether or not they're positive or negative. What other numbers multiply to 8? Well, that would be 2 times 4. Now that's a candidate. If you add them, you'll get 6. Now we want to be careful because we don't want a 6. We need a -6. But if they are both negative, we should be okay. Double check it before we go any further, okay, with this. -2 times -4 gives me +8. And some of you are really fast and loose with whether or not a number is positive or negative, and you can't be. You have to know whether it's positive or negative, have to be paying attention to it. So negative times a negative will give you a +8. -2 plus -4 will give you the -6. So we have found our number combination. Sometimes people will call that like the key number combination. If you were in an Algebra 1 class that did diamond problems, that was essentially the essence of diamond problems. Okay, so now what we're going to do is basically what we found out is that like one of these is -2x and one is -4x, but I want to be really, really careful about how we go about doing this because there's a weird like sign, like if you end up with a negative factor, that, oh my goodness gracious, I have a cat on my lap and he's not cooperating at all. Okay, he just left. So just follow the steps as I'm going to provide them because it will avoid this like weird little thing. So pick one of those numbers, either number. And if you look up the notes on the Wakelet, okay, so if you're looking, which is probably where you found this video, but if you're looking up the notes on the Wakelet, you can see that in the notes, I actually did it both ways. I used the -2x and I used the -4x to show you that you get the same answers either way. So I guess for the video, I'll go with the -2, and I'm going to put that in the upper right. Okay, it doesn't matter. You can use -2x or you could use -4x. And you know that that's going to be your x term because if you do enough practice problems, then you know that these upper right and lower left are going to be the boxes with the x. We were just looking for that coefficient. Now what we're going to do is factor out the GCF going to the left, like so. Okay, and this is where if you blew off the GCF lesson, even though if you're period 7, I like tagged you in a post, like if you blew it off and you didn't practice it, you need to stop this video right now and you need to go make sure you watch everything you can on GCF factoring because it will, like you have to know how to do that. This builds on that. So if you need to, you can do a little prime factorization here, but I wouldn't recommend it. And hopefully you can see that the greatest common factor here is an x. And so we're going to factor it out. Basically, we're undistributing. We're reversing the process that we were doing when we were doing the multiplication. Okay, and once we have that, now listen to the thought process, okay? If you're looking at the notes, it says use the rectangle to figure out the other pieces of the factors. So that was all we needed to do, and here we go. So the area of this is x squared. X times what would give us x squared? Well, that would be another x. That's where the x squared would come from. X times what would give us negative 2x? That would be a negative 2. Looking at this, negative 2 times what over here would give us the 8? Well, negative 2 times negative 4. And notice that we have our factors. Our factors are going to be across the top, x minus 2, and down the side, x minus 4. Now, you're thinking, well, what about this here? This I want you to use as a check, okay? You should, when you multiply negative 4 times x, you should get the other number, whichever one you didn't use. Okay, now the reason I want you to do it that way, instead of just filling in the negative 2x and the negative 4x, is because of this negative right there, okay? If you do them both at the same time and you try to do GCF factoring in all the directions, you can end up over factoring out a negative. So I really want you to follow the process that I gave you. Rest of this video, we're going to look at some special cases and just try to rehearse this process so you get a chance to see it a little bit more. Next example that I had was x squared plus 3x minus 18. So we'll go through this a little bit faster. We set it up. We're going to put in the x squared and we're going to put in the negative 18 because we know that those are going to go in those locations. Now we're going to multiply a times c. So a is 1, c is 18. It's actually a negative 18, so just be mindful of that, okay? And they need to multiply to negative 18 and they need to add up to 3. So what kind of numbers do we have? Well, 1 times 18. Now notice I'm kind of ignoring the negative. I will come back and address that. So 1 times 18, if you add them, you get 19. If you subtract them, you get 17. Definitely not getting a 3. 2 times 9. If you add them, you get 11. If you subtract them, you get 7. Still not getting a 3. 3 times 6. If I add them, I get 9, but if I subtract them, notice if I do 6 minus 3, I get the 3. So we have a winner. We just have to be careful that we get all our positives and negatives right. So I need those to add up to positive 3, which means that the 3 needs to be negative and the 6 needs to be positive. Before you go dump that into your rectangle, double check and make sure that it's going to work. Negative 3 times positive 6 is negative 18. Notice that I'm not ignoring the negative forever. I just kind of ignored it to generate the number pairs. And then negative 3 plus 6 would give me positive 3. Doesn't matter which one of these you pick, so I'm just going to go with the negative 3. That'll be an x. And the hard work is done. GCF. X squared minus 3x, the GCF is x. And now think to yourself, okay, it's an area model. So x times what gives me x squared? And that would be another x. X times what up here would give me negative 3x? Would that be negative 3? And then right here, negative 3 times what would give me negative 18? Well, that would be negative 3 times positive 6. So your two factors are x minus 3 across the top and x plus 6 across the bottom. And then use this square as a check. 6 times x gives me 6x, which does, oh, not right there, but right there, does match my other numbers. So you can use that as a check if you make a mistake somewhere along the line. That won't work out. Okay, so there are a couple of special case things that we might want to look at. One is called the difference of squares, and I want that vocabulary to make sense to you. So here's the example from the notes. X squared minus 4. Difference, of course, you should know, means subtraction. behold a subtraction sign. And then squares means that you're dealing with what are called perfect squares. And so we have x squared, and then if I wanted to, I could rewrite 4 as 2 squared. Okay, and so it's looking at a the number part, and the number part should also be something squared. So there's a couple of ways that you can do this. I'm going to do a quick little rewrite on this, and we're going to employ my favorite number in there. And I want you to, like, if you need to pause the video here, pause the video. X squared minus 4 would be the same as x squared plus 0x minus 4. Okay, and you might be wondering, well, of course, but 0 times x is 0, but why did you bother writing it in? I'm writing it in just to remind us of what the b value is. So let's go ahead and set up our rectangle. And we're going to put in the x squared, and we're going to put in the negative 4. So now we have 1 times negative 4. So we are looking for two numbers that multiply to negative 4, and they have to add up to 0, which means that we need opposites. So 1 times 4 doesn't do it. If you add them, you'll get a 5. If you subtract them, you get a 3. 2 times 2, that should work, because if one of those 2's is negative, we should get what we need. So 2 times negative 2 is negative 4. 2 plus negative 2 is 0. And we have one that works. So I'll go ahead and put the 2x in. Again, factoring out the greatest common factor, you have x. And then it's the same process. So x times what gives you x squared? That's going to be another x. X times what gives you 2x. That's going to have to be a 2. You can kind of visually go back. One of the things I like about this method is you can check each piece of it. So x times 2 should give you 2x. Like, you can kind of go back and just do a quick little check and see if what it is makes sense there. Now we need to get this. So 2 times what would give you that negative 4? That would be a negative 2. And so our two factors, that's positive 2, would be x plus 2 and x minus 2. And then as a check, do this real quick. X times negative 2 gives me negative 2x, and it matches my other number. Now, super, super important vocab word here. Okay, these are called conjugates. I'm pretty sure that's on the homework. I'm pretty sure that you're going to see that a million times. Okay. All right, now the last things is just a couple more examples. So I've got about 7 minutes left in the video, and I will try to do 3 examples at that time. We'll see how it goes. So example 6 is 2x squared minus 9x minus 18. And just note that a is equal to 2, b is equal to negative 9, c is equal to negative 18. Set up your rectangle. Put in your squared, put in your constant. Now, this time we actually do have some multiplication that we need to do. So we need to do 2 times negative 18, which gives us negative 36. And we kind of cringe a little bit because, ouch, that's a big number. And we need them to add up to negative 9. So we're looking for two numbers that are going to multiply to give us negative 36 and add up to give us negative 9. And so we can start listing those factors. 1 times 36 won't do it. You can get 37 or 35, but definitely not a 9. 2 times 18, that if you add them, you'll get 20. If you subtract them, you get 16. So that does not work. 3 times 12, and you might have to sit there with the calculator and just kind of divide these out. That one should work, okay? So if we have a positive 3 and a negative 12, so let's double check it. 3 times negative 12 gives me the negative 36. 3 plus negative 12 gives me the negative 9. Go ahead, dump in the 3x there. Factoring out the GCF, so we have 2x squared plus 3x. Greatest common factor is x. And now x times what gives me 2x squared? That would be 2x. And again, if you're not sure, do a quick multiplication there. 2x times x gives you 2x squared. X times what gives me 3x? So that's going to be 3. And then move down to figure out this. What times 3 gives me negative 18? So that would be negative 6. And so my two factors are right there. So we have 2x plus 3 and x minus 6. And then please do that check there. 2x times negative 6 is negative 12x, and that matches your other number. So you know you have done it correctly. And of course, at any point in this, pause the video, take a little bit longer, rewind it. It is the beauty of the internet. So next one is 6x squared plus 11x plus 4. Setting it up. We have 6x squared and we have a 4. We actually do need to do some multiplication there. So 6 times 4 is 24. And we are looking for two numbers that multiply to give us 24 and add to give us 11. If you know them right off the bat, you don't have to list them. But we have 1 times 24. Does not add up to 11, add up to 25 or 23, depending on if you make one of them negative. 2 times 12, that does not work. They can add to give you 14 or subtract to give you 10, close. 3 times 8 should work though. If we have a positive 3 and a positive 8, it should work. So that, I guess we'll go with 3x. Be careful when you're doing your GCF. The GCF here is actually going to be 3x because this is 2 times 3. So you can factor out the 3, and then they also have the x in common. Remember what I said. If you blew off the video on greatest common factor factoring, you have to go back and watch that. All right, what times 3 would give me 6? Well, that would be a 2. And then what times x gives me x squared? That would be x. And if you're not sure, do a quick multiplication. 2 times 3 is 6. X times x is x squared. What times 3x gives you 3x? Hopefully you know that's 1. And then down here, what times 1 would give you the 4? That would be 4. Again, do a quick check there. So our factors should be 2x plus 1 and 3x plus 4, and do a quick check. 2x times 4 would be 8x, and that does match our other number. Last example that's in the notes is one that has multiple types of factoring in it. So if you have x squared minus 22x plus 20, what you should notice right off the bat is that all of these are even numbers. And if they're all even numbers, it means you have a common factor of 2, which means you can take out that factor of 2. And what that does is it makes all of these numbers smaller. So you're not doing 6 times 20 to get some like hideous 120 that you're going to try to factor. So now we're factoring 3x squared minus 11x plus 10. 3x squared, here's the 10, and we're going to do 3 times 10 to get 30. So we're looking for two numbers that multiply to give us 30 and add up to negative 11. 1 times 30 won't work. 2 times 15, closer. 3 times 10, nope, that does not give us 11. 4 times, not anything. 5 times 6. There we go. So if they're both negative, so negative 5 times negative 6 gives me positive 30, and negative 5 plus negative 6 gives me negative 11. So I'm just going to go ahead and grab the negative 5x. And I like that because my GCF is just the x right there. That gives me a 3x right there. Because 3x times x would give me the 3x squared. This would have to be a negative 5. You can do a quick little, yep, that's right. Negative 5 times what would be out here to give you the 10? That would be a positive 2. You can do a quick multiplication there. So our factors are 3x minus 5 and x plus 2. Do that quick check there. That gives us 6x. Oh, wait a minute. Oh, this has to be a negative. Caught it. Okay, that's a negative. Shoot, I'm running out of time. Negative. There we go. And lo and behold, my check worked because I caught the mistake there. Now, don't forget, over here, we took out the 2 first. So when I'm listing my final answer, I need to make sure that 2 is still there. And with 5 seconds to spare, I finished the last problem in the lesson. Hope this helps if you missed one or more lessons.